So welcome everybody. Welcome to this session about code readability and how to help others reading our own code. As a sort of disclaimer, I would like to make it clear since the beginning that I'm going to illustrate a few points, but that's just my perspective on things. So when I present an excerpt from this presentation in classes, in software design classes, inevitably, each and every time, there is someone who challenges, who argues about what I recommend has the right way to go, says, no, but I don't think that this is as readable as this other approach. So everything here is essentially, oh, one guy in the back. So everything here is absolutely relative, except one point, that being consistent in whatever you do, right or wrong, okay, is probably the most important thing. Because when someone reads your code, it is someone that is trying to follow your mental reasoning. And the best help you can give him or her is just being consistent. So doing the same things in the same way and showing some sort of common way of doing things. This is the best help you can do. And this talk was inspired by an experience that I had not that many time ago. To give you a little bit of context, I'm now responsible, one of the roles that I cover in the industry today is being a technical evangelist for a company called Scientia Mobile, and this company is responsible for a library called Wurfel, which is used by two companies in the world, Facebook and Google, to set up their mobile websites. So essentially, this library is available in .NET. It's available for a number of languages and platforms, Java, PHP, Ruby, whatever. I'm responsible for the .NET library. And I wrote this library starting from a relatively large Java code base. So as I made my way through the Java code, several times I noted points. I took note of these points, and then this presentation came up. So this is essentially a survival guide for others. In a way, when the UEFA arranged the championships, the European championships, last year, I noted this respect slogan. Respect the opponent, and I like to say that we need respect, but for other developers. And other developers who may happen one day to work on our code should not be seen as the opponent, but even if you want to look at other developers as the opponents, at least try to respect them when you write your code. Okay, it's a matter of regard, for sure, for other people, other colleagues. It's a matter of courtesy, of course. It's a matter of education, of knowing how to do things, being valid professionals. So it's, of course, a matter of professionalism, a matter also of being good citizens in the world of software development. But the main point is that the other developer one day might be you. Okay? And this is a very nice comics that attempts to show what is the experience that everybody went through, or usually goes through, when wades through someone else's code. It's like a forest for us, and we try to make our own way out of this forest, and everything we find, oh, it's crap. Who wrote this piece of crap? It was such an idiot to write this code. And sometimes we find structure, and we can hardly make sense of that. And everything looks like, a wall, okay, so a barrier, some sort of a hurdle, but with a ladder ready to go over there. And you cannot make sense of why we have a hurdle and then a ladder to go through. Why? Okay, in Italy we have an answer. for that, because there should be some sort of, some people, some politicians, and who needs to make money out of that. A situation like this in Italy is fairly common in the south, because there's an highway that is been in construction for 30 years now, is not even finished, and then they have tunnels in the middle of nowhere. So there's not a mountain with a tunnel to go through. There is, just seaside landscape with a tunnel there, and nobody can make sense of why this structure is there. Similarly, in code, less expensive actually. Similarly, when you find a long path ahead, an algorithm that is being started, and you can hardly make sense of that. Where could this bridge possibly lead? Who knows? And this is beautiful. Commands. Commands. How many times you found or you put in your code stupid commands like this? Yep. I'm the first. Also, the guy in the back there. Hadi. How many times? Okay. It's not really helpful. Obvious, stupid commands are not really helpful to anybody. Maybe when we put these commands in the code, we do that with the best intentions, because at that time, that command seems meaningful. You put the command as a note to self to become important later. But a point that we often forget is that every command in code is code. So it is subject to refactoring. And a common mistake that everybody does is leaving command there because it's command that it doesn't affect code. Yes, right, it shouldn't affect the behavior of the code, but it does affect instead the experience of whoever happens to work on our code at a later time. How many times you think, but what a horribly designed structure. It's inefficient. Everybody sees this or judges this. And when this happens, it's because we are right, okay, in spotting complicated, sophisticated, articulated path algorithm, okay, implemented somewhere. And we can hardly make sense of why that kind of thing has been done that way. And normally, usually, naturally, we think this is badly done, but we base our judgment on what we see at that point. We have probably no further vision, no enough perspective on things. And how many times happened to you at the end of the story? So when you're done, you say, oh yes, it's probably not the best and most elegant solution, but it was the only possible solution. But when we look at this kind of things, oh, this is inefficient. I need to modify, I need to change, I need to fix, I need to refactor this code. Not to mention contraptions that we find, and from the outside, we judge those contraptions like, useless result of bad programming, poor practices, but we don't know why that contraption has been there, because maybe of requirements which change it over time with no time and no budget to fix, to refactor enough code, or the will not to refactor. Who knows? But still, this is what we find, and in the end, everybody hates reading other people's code. Putting our hands on other people's code is never considered, a beautiful, pleasant experience. Okay, what can we do? Why people hate reading other people's code? Here is an example. Apparently, okay, this is a piece of Java code, and a piece of Java code that I found in a real code base. Meaning list. It took me seconds to figure out the name of the function in first place. Basically, it takes a list of integers and just calculates the minimum out of a list of numbers. The method is private. And there is just in the code where I found in the file, in the source file where I found this excerpt, it was called only once like this. Where is the problem? Where are the problems, actually? Number one, the name of the function. The convention used is at least arguable. The name is, I don't know, mean in least. Well, the name can be even correct. The convention is arguable, meaning, I don't know. It's not a name that I really feel I like and find explanatory. Second point, looking at the way in which the code is used, you don't need this code. It's overkill and time wasting. You only need to calculate the minimum in between two numbers. As far as I know, math.min will work without any need of writing extra code. I'm not questioning having a function like this. Get the minimum out of a list. Okay, in .NET, we will probably use link. In Java, they do not have link. Poor guys. But anyway, I see here, I think I see here, what was the approach of the developer who wrote this code. He essentially applied Yagni. You ain't gonna need it. The opposite. You ain't gonna need it. So have code only when you need it. But if we follow the Yagni philosophy straight away, we never write any single line of code that makes for future extensibility of our code. So Yagni is a great principle, but it has to be applied with a grain of salt, because otherwise Yagni would prevent any further. So, and every time you need to add a feature, if you don't try to think ahead a little bit at least, every time you have to refactor entirely the system. So I see the effort here, which was that, okay, I foresee that somewhere else in my code base I may have the need of calculating the minimum in a list of numbers. So where the number of integers is higher than 2. So he wrote a general routine. Except, so his sense of reusability is fairly limited because the function is private. At least make the function public, or, okay, changing private to public takes a second. But on the other hand, if it's private, there is no chance you can use this elsewhere. And it is confusing me as I try to read your code, because I find a general piece of code that looks like part of a possible framework marked private in place. So this is just a waste. The same code could have been achieved with a simple math.min, and at least the function with a better name and made public. This one, oh, Apple, thank you. Kill Apple. How is it possible that this Apple controls us? And thanks God I'm not talking about iOS. Anyway, the recipe for better improved readability. 3C. Commenting, consistency, and clarity. This is just a screenshot taken from the PDF of my next book, written in collaboration with my 15-year-old son, building Windows 8 applications with HTML and JavaScript. Why am I putting this here? Not certainly for advertising, but because this is the first book ever I wrote for absolute beginners. And like it or not, agree it or not, but I felt the need of making it clear, even to absolute beginners, that code readability is an attribute of code that is not just reserved for experts. because experts couldn't care less of readability. You are an expert, you can read everything. Okay? So readability, in a way, is probably much more important if it is taught to junior developers, to newbies, and it's a kind of an attitude that can be adopted right at the beginning of any programming career. Commenting and comments. Today, probably every developer uses ReSharper or similar tools, code assistant tools that help us writing code. And IDE tools in general are much smarter today than they were 10 years ago. So this means that a lot of the reasons that we had for putting comments in code 10 years ago are today removed by the help we get for free or for a few €100 from tools like ReSharper or even native tools in Visual Studio. So we have IntelliSense, and IntelliSense is based mostly, for the most part, on documentation, on using reflection to figure out a list of methods. So we have a lot of help, okay? And this, in a way, reduces the need for comments, for having a lot of comments everywhere. What we need to have, and essentially, we still need to have a lot of institutional commands. What is what I call an institutional command? It's essentially something, a small, concise, but precise description that we find for every public piece of code, just to help tools to pop it up. As we move and we extend and we invoke those methods in publics. So it's still kind of mandatory for you to use commands on top of classes and on top of methods, describing parameters, describing one sentence, two sentences, behavior, return values, and so forth. This has to be mandatory in all public pieces of code. You can probably skip them in private methods and private classes, as long as they have no relevance outside the current file. And this is institutional commenting. What else? We have obvious, stupid commands, and we have insightful commands. This is a command, like in the comic, is an example of something we want to ban from code. A command, and I think that you can take a similar text right from any dictionary that explains what a command is. A command is a synonym for command is remark, and a remark is an annotation you make on something else, in this particular case on a piece of code. So a command has to be any explanatory text for what is or may not be that obvious by itself. It has to be a remark, insightful, never obvious. If it's obvious, this is a command style, you should be able to detect that and drop it. And probably you will never do this on first pass. So the concept of refactoring should be extended also. So when you refactor code, you should also include comments in the code you refactor. The first code on top has essentially one comment per line. Get device type. If device is a tablet, collect data for the tablet view. Now, we are developers, right? We may be Java developers dealing with C# code, or C# developers dealing with Java code. But unless we are using Objective-C, which is another language on its own, which deserves detailed explanation for every single byte, we should be able to read code. We have we master the language. So commenting every single line, you can hardly have a comment on every single line. My wife often asks me, but why don't you call your mother? My mother lives hundreds of kilometers away. And I talk to her maybe once every week, once per week, maybe once per every 2 weeks. And my wife says, but why? You don't, you are so you don't care that much about, your mother, and you don't feel the need of talking to her every day, because I don't know what to tell her every day. Maybe in a week or 10 days, I sum up a number of topics I can talk to her about. So the same is for comments. You need to have some work done before you may feel the need of commenting. Okay, unless you are like my wife, and in that case you fall in the category of developers, okay, who wrote probably the code you see on top. This is probably a much better way of commenting, of using comments in code. Some people may argue that this is too much anyway. I'm a developer. C# or Java or whatever it is my first language. I first speak C#, and then my second language is German, my second language is English, or whatever it is. Okay, but your first language may be C#, but my first language is still Italian or still English. Okay? And so comments are still need to have a place in code. And it's all about finding a measure, the right balance between the skills of people reading your code and your skills. C as consistency. There's an old proverb who says, when in Rome, do as Romans do. So when writing code in Visual Studio, or when writing code in any other IDE, or in any other language, when it comes to commands, do as locals do. Or when you work for a company and this company has guidelines, play by the rules of those guidelines. The point here is not much whether guidelines are right or wrong. Being a good citizen serving as a developer also means that you should be able to accept rules, guidelines that you haven't contributed to. Developers tend to be independent spirits. I know the way I write code is unmatched. Nobody can write the code I write myself with the same sense of clearness, cleanness, conciseness maybe, effectiveness. Nobody else. So when you join a new company or you work with code written according to other guidelines, the first thing you question is the guidelines that you may don't like. Of course, this is something you should avoid. And I would like to say that whether guidelines, and here by guidelines I'm not necessarily talking about guidelines on how the code has to be written and organized. I'm not talking about software design principles, right? I'm talking more about naming conventions. The point is not much whether this kind of writing styles and guidelines are right or wrong. The fundamental thing is that there is consistency, that things are done and explained and approached always in the same way, because this is a fundamental point that helps more than anything else other people trying to read your code. So if your company has a significant amount of turnover with new developers joining the teams, or with developers moved from team to team with the need of using and working on others people's code, consistency is the primary asset for the team and for the company. To the point that I would even suggest that some critical aspects of the writing code guidelines are enforced through policies. In which way? I mean, you could even imagine a scenario where your code is not accepted in TFS or analogous tools if it is not compliant with some guidelines. Now, the next question is, okay, how do you enforce these guidelines? And, okay, using tools and maybe ReSharper or analogous tools, they do have a way for you to create a template, for you to create a sort of rules that can be enforced, evaluated before the code is checked in. It's not a big deal, but one of the companies I worked for recently, they had a very basic, simple check-in rule that was not accepting anything if any file that was lacking a header at the top. So they just had very simple, basic parser, just checking the beginning of the file. But I mean, that was enough to at least to remind developers, hey, look, you are missing this piece of code. So I really don't know what is a step-by-step procedure to enforce through policies consistency through your code. But if that comes to be a problem, serious problem that really compromises code readability, this is a possible approach to take. But the best of all is developers natively implement the I am consistent interface, so self-discipline. Sense of code consistency, part of the cultural baggage of individual developers, and another reason why I decided to put a call out on code readability also in a book that, according to the publisher, will only be of any interest to absolute Windows 8 beginners, so 3 people in the world. Trying to go a little bit deeper, here is a list of aspects that in terms of coding style can be of interest. Of course, indentation, but today indentation is free, comes out of the box with editors and code assistant tools. Naming conventions, of course, is naming convention. Once, when I started this career, back in the 90-something, at the time of Windows, in the pre-Windows 95 age, with dinosaurs, walking outside of the windows, there was a beautiful, fantastic naming convention called the Hungarian notation. The Hungarian notation was based on everybody had something against, even at the time, against Hungarian notation, but nobody could find anything better for years. The fundamental point of the Hungarian notation was every variable, every function starts with a prefix that identifies the type or the return type. So and for reasons that are still today beyond me, strings were identified with the SZ prefix. I wrote countless times as Z buffer, as Z temp. How many times? I mean, million times in my code. Of course, the Hungarian notation was built around the idea that every variable should be self-describing in terms of the type. But it was a different age of programming in which essentially we had, before Windows 95, okay, C++ was, of course, a mainstream programming language. Java was a growing programming language, but for the most part, Windows developers, were using the C language. In the C language, we had no classes. And that means that most of the code was written using primitive types. So string, integer, so spotting at a glance whether a variable was a string or a variable was reckoned useful. Of course, with the advent of classes and object-oriented programming, the Hungarian notations lost, all of its importance, because we now need to focus on what the object is, what the behavior, more than on the syntax of the name. But anyway, following naming conventions for class names and their public members and also variables is still helpful. So whatever is the convention, it doesn't really matter, whatever is the convention, but as long as there is one convention around the company. And at that point, I would even say that it's not even important who writes that, as long as there is one and it is applied thoroughly in the company. Not just, public members of classes, but also local variables and temporary variables. And the fundamental example here, the basic example here is with JavaScript. In JavaScript, and even in Java, method names begins with follow the camel case. So the first chunk of the name is lowercase, and then next words are camel case. In C#, everything is Pascal case, in which every word composing the function or variable name is Pascal case. So you might want to stay with that. And more importantly, to achieve consistency these days, the best way and the easiest way is using tools, code assistant tools. With a click or two, they can help you out. And you may argue, yes, but tools force me to use their own set of coding styles and guidelines. But my perspective on this aspect is I don't care, as long as my code results written in a consistent way. And not to mention that code assistant tools are customizable to a large extent, so you can even change some of those internal rules. Another point, so beyond naming conventions and beyond, of course, indentation, is the size. Size of methods and size of individual lines of code. And then calls to functions, or implementation of small tasks that should be done the same way, but more in detail. Clarity. I will return on this aspect, size in particular, in a moment. Obfuscated code is obfuscators are tools popular in .NET because they make the code hard to read for insiders. But there was a time in which, especially it was when the C language was popular, in which writing obfuscated code that others could not read was a serious joke. There is still today the IOCCC.org. If you go IOCCC.org, they run every year a contest between C developers, and the winner is the one who can write the hardest to read code that does implements a behavior. If we have an internet here, if it's still there, I would like to try to offer a perspective. And the winner of last year, October 2012, was this. Well, I don't know exactly what this code does, but And the first time I heard about this international contest was, at the beginning of my career, and the code was, a line like this, and I even compiled that code, and it was "Hello World." So it was saying just "Hello World." So I don't know exactly what this code does, but this is a great example of code written not to be read. We want to achieve possibly the exact opposite. So obfuscated code in this world is no longer trendy. In the previous slide, I said do the same task the same way. I would like to rephrase that point using the idea of the Occam eraser of code. For example, there are many ways in .NET code for you to check strings for equality. You can use string.equals. You can use the equal operator. And maybe there are other ways as well. If you make a point of always using the simplest and clearest approach and stick to that, that will immediately, at nearly no cost for you, make your code much easier to read. If you believe that I'm exaggerating, I'm trying to say a lot of bullshit just to fill up this presentation, well, the only thing I can oppose to this possible and legal, legitimate perspective, okay, during my experience porting Java code to .NET for the Wurfel library, at some point, in several places, I stopped because I was finding that the other developer was using different approaches to check for a substring in a given string. In some places, he was using dot substring, or whatever is the equivalent in Java. In other places, he was getting an index, the index of the substring in the given string, and then checking the index against 0 or a negative value. Now, the point is not what Java architects and C# architects and .NET framework architects did. Makes sense to have a substring and index of in a framework or in a language, because substring gives you a Boolean answer. Okay? Whether this substring is contained or not. Index of gives you the index, the zero-based position where the given substring starts. If the substring is not there, you get a negative number. So, looking into the returned value, you can arrange an algorithm of yours to check whether a substring is contained in a given string. But index of and substring serve different purposes. So it's about you. It's not about .NET developers. And when you find here and there in different places a substring checked once against index of and once against a substring, you, as a conscious developer, you should stop there and wonder why. If there's something there that you are missing about the index, if the index is returned and saved to a local variable, why is there? Okay, is it being checked just for checking if it is equals or greater than 0 or not? But why the index is there? Maybe there's a reason, and you spend time there and multiply this by, I'm talking about a substring function. Imagine in a 300,000 code base, lines of code base, how many times you can find this kind of code, especially in a library that makes string manipulation, where string manipulation is the core business. And it means that every time you waste a bit of extra seconds and your work and your sense of comfort is put at risk. But is it true what I'm... Okay, I seem to have learned something about this code, but is this correct? Can I be correct? Why this guy did the same thing in a different way? So, if you can put an effort to always do the same thing in the same way, that would be immensely helpful. Grouping and nesting code. There's a tool, I don't know exactly if Microsoft is still pushing that tool, what's called Style Cop. I installed Style Cop for Visual Studio 2008 a few years ago. I was told that it was updated for VS 2010. I don't know if it's dead or if it's still available or in preparation maybe for 2012. The reason why I uninstalled Style Cop, like FX Cop, essentially looks into your code for a different set of rules. Style Cop is just questioning your style when you write code. So it could be the perfect tool complement to try to improve readability. It does essentially a subset of the things that tools like ReSharper, Just Code, and Code Express do, except that it's free. The reason why I uninstalled that is because it was complaining about the application of this point in my code. When some tasks require 3-4 lines to be completed, so they are part of the job that a given method is implementing, I like to keep these few lines, 3, 4, 5 lines, no more than this, separated with a blank line before and after. And StyleCop was complaining about blank lines in code. Maybe there was a way to disable that feature. I couldn't find that way in a short amount of time, so I opted for completely uninstalling the tool. Okay, I will take care myself of guidelines, my own coding style. But beyond that, so grouping lines, correlated lines of code helps sending the message to readers that those lines stand out. So they represent something that is significant in the algorithm being implemented in the code. So you know that at that point, something that makes sense, that you should make sure to understand very well, is taking place. Another aspect is nesting code. It's dreadful. I try to avoid personally if statements. If, then else, with branches, with long branches. I try to avoid as much as I can if statements. And also, for the same reason, I don't like that much delegates and functions being passed as arguments. But anyway, we are now in the realm of personal preferences. So what I like and what I call out as a do thing, other people in this room and outside may say, no, I don't think so, you are wrong. I do things in other ways. But anyway, whatever is your position, learning from open source projects is always a good thing. All open source projects I've checked personally, looking into the source code is very well written, and from a style perspective, stand out. So you can borrow techniques, tips, tricks for writing code from many open source projects, because they are written very, very well in terms of style and then readability, because they are, of course, being open source projects, they must be understood for people to fork, for people to contribute or anyway create extensions and variations. Other aspects, short is better. And 2 slides ago, I had a point about the size of methods and lines. Have you ever wondered why newspapers are printed in columns and not, they never develop horizontally? So the article goes like this and never like this. The paper, it may be like this. Why? Because studies seem to confirm that the human eyes find it much easier to read short lines than long lines that develop horizontally for a significant amount of space. So when you write lines of code and subsequently when you write methods, horizontally and vertically, you should try to keep your code limited in size. For lines of code, you can sometimes use, you can take advantage of, syntax. For example, a typical line that takes long to develop horizontally is, for example, a line in which you use the if operator, question mark, column. At that point, break the line and put the options on the wrapping line, on the next line. That will cut at least by 50% the length of the line. Another point is when you have a function with a long list of parameters, at that point you might want to put every parameter on a different line. So find out ways to keep your lines very short. And the rough rule of thumb I use myself is the size, the full screen window, and regular font size in Visual Studio. Everything has to fit into what I see. So I would like to have Visual Studio with no scroll bars, or at least just possibly the vertical scroll bars, not certainly the horizontal scroll bar. If you're looking for a rule of thumb, this could be a good one. Methods. When a method takes more than 20, 30 lines, it's likely that the method may need, the method and what it represents may need some refactoring. It makes no sense these days, to have methods particularly longer. Okay, one exception is the method is implementing an algorithm. It's an algorithm in which you have to test 300 different situations. At that point, probably, okay, if or a long switch statement is probably, it works anyway. And also because an exception, writing that in other way would involve creating classes over classes with injection interfaces. That would probably make the entire thing a lot more sophisticated and complex. So with due exceptions, methods, when they are beyond 20 or even 30 lines of code, they likely need some refactoring. Or put another way, there is some refactoring that can be applied to that code to make it cleaner to read and also cleaner to maintain in the future. Because of course, we are focusing on readability, but readability is strictly related to maintainability. And maintainability is key for code. 70% of the code today is maintaining existing code. Very few companies, very few teams work on brand new projects. Everybody is maintaining, or almost everybody is maintaining existing code, or writing code that has to last for years and years. Folders and namespaces. Another feature that you get for free out of tools called assistant tools that can enforce that there is a one-to-one match and correspondence between the structure of folders in the project and on the file system. There is no way for you to ignore this. No good reason I can think of. So it comes almost for free, given of tools, and a good organization of folders and subsequently code sets the base ground for a good organization of code and logic. Dry, don't repeat yourself. I mentioned Yagni a few moments ago. Dry is another key principle. There are two principles in software design that apparently are similar, if not identical. One is dry, don't repeat yourself, and the other one is once and only once, OAOO. Once and only once, don't repeat yourself. If you don't repeat yourself, you do things once and only once. Well, the difference, if you want to be picky, between don't repeat yourself and once and only once is that the first, don't repeat yourself, applies to data. So store data, get data, always in the same way and possibly always from the same repository. Once and only once is a little bit more ambitious, as I say things, because once and only once is the same as normalization in databases. So it is the final goal, of any refactoring effort. Any piece of code you may need, any piece of logic you may need, should not be duplicated. So whatever action you need to code has to be coded once and invoked and referred by parts. Like in relational database modeling, sometimes a bit of redundancy is useful. The same happens here also. Once and only once is not necessarily something you can really achieve. It's the ultimate goal, the ideal goal, the vector that shows the direction to go. But you can hardly, at least in my experience, really come up with a system where every single piece of code never duplicates logic. Always in the same way. If you do things, if you need to do an action, for example, checking a substring, do that always in the same way. And unused references. It's fairly common when you create a new project in Visual Studio that you find the project, even the empty project, I have in mind the ASP.NET MVC, has tons of references to libraries that you don't use, or at least that are not required as long as the project is empty or very, very basic. ReSharper and other tools have a nice function: check unused references and remove them from the project. Ensuring that you have no unused references and no unused namespace references in your code is helpful and increases readability, because if you can give people, the readers of your code, the feeling that everything I find in the source files has its own role, is here because it's required. If you start giving the opposite feeling to people, everything I find here, is it really required? Remember why is this piece of crap? Where is this possibly inefficient bridge leading? So all of the messages you may remember from the comic is dubbed in the mind of readers, and this takes time for him or her to understand your code, and is essentially in the end a loss of time and a loss of money. So unused references, this little thing takes 3 seconds or even less with a tool to remove. There's really no reason to ensuring that there is no extra unused line of code, unused using statements, and unused DLL assembly reference in your project. I use ReSharper, so I can mention ReSharper, but I guess that the same happens with any other analogous tool. With ReSharper, it just takes 3 seconds, and really there is no reason for this, for not doing this. Yeah. When I talk about this, readability, write code with care, there is a common objection. Yes, but I don't have time to write code in a clean way. Writing clean code, elegant code, well-styled code is hard, and I'm a serious developer, I'm a busy developer, I work for an important company, I'm a great asset of my company. I cannot waste my valuable time writing code as any other nerd out there. Okay, use a tool. The expression sustainable development is usually used for more serious things, having to do with the growth of the economies in the world, the impact they may have on countries in other parts of the world. But I like to use the expression, to borrow the same expression, sustainable development, to push the idea that writing good code, writing clean code, is a sustainable effort, even for busy developers who think or really are key assets for their own companies. No matter how busy you are, no matter how many projects you have to work on, no matter how many people you have to manage, no matter how smart is the code you write, there is no reason for not making your code easy to read. And, okay, there is one reason, actually, and it's optimization. Because when it comes to optimizing the code, maybe for performance or for other aspects, okay, that is probably the only point in which you should sacrifice good style and readability in return of some extra CPU cycles. But with the exception of this particular aspect, there is really no reason for not trying to write clean code. And if you have no time, or if you are not implementing the I am consistent interface natively as a developer, there is no reason for not using any of these tools, ReSharper, Code Rush, and Just Code from JetBrains, DevExpress, and Telerik. There is no reason for using any of this for the 100, 200 euros of license they cost. Everything, or 90% of the guidelines that I listed in this talk so far, can be achieved with just a few clicks, that after a few weeks of usage become natural. As you type, you right-click. As you type, you right-click. As you type and write, you look. As you think, you right-click. So after a few weeks, it's just free. It's just part of your job and makes you addicted to any of those tools. But the final result for the company is that your code is extremely and significantly cleaner. And here is the result of applying one of those, a tool like ReSharper, for example, not just enforces a fixed style on the name of methods, the name of local variables, but also suggests a few guidelines on how you actually format your code. And every time you have, or almost every time in which you write a for each loop in a C# code and you have a ReSharper installed, you see the balloon icon that pops up suggesting you turn the for each statement into a link expression. Well, honestly, I find that the for each statement is one of the clearest in the world. And to enforce this point, let me share a small anecdote that happens Sunday. My son is 15 and is doing a lot of serious, professional, mobile development. He was last Sunday, was trying to map a piece of Objective-C code on a monotouch class for iPhone development. So at some point, he said, "Dad, I need help." Okay, what's the problem? "What's this?" And he showed me an Objective-C line. Now, when I see Objective-C, I feel physical pain. So yeah. So okay. Let me see. So I approached him. I tried to make sense of that text, and I figured out that they were trying to pass a function pointer to an array to have the logic embedded in the function pointer executed on every element in the array. So I said, well, it's just like, what a for each is? Of course I know. But Dad, I'm a serious developer, right? You asked me if I know what is a for each. Okay, it's a for each, in which for every element in the array, they execute this function. And why on earth they didn't use a for each? And this reminds me of some of the suggestions we get from ReSharper that suggest we replace a clear for each with a link expression, which most of the time is about passing a delegate, okay, that will be automatically executed for all of the elements in the collection. Honestly, I don't know why ReSharper is pushing this approach to code. But for sure, once the code has been transformed by ReSharper, it's more compact, for sure. But sometimes I'm not sure that if I approach a code that uses a combination of select, where, group, in a complex link expression with let statements in the middle, I'm not sure that I will be able to make sense of it at first time. Written as a for each, no doubts, no problem. So what I do most of the time is I write my code in a for each, using a for each, and then case by case, I decide whether to turn that back into a link expression as ReSharper may be suggesting, or keep it as a for each. Nothing is clearest from the understanding perspective than a for each statement. But sometimes ReSharper suggests you rewrite this code like this. And honestly, this is a suggestion I like to accept. I nearly accept every time. But also, when I discuss this in conferences and in classes, most of the time there is someone who disagrees and considers this code anyway clearer than this. This is to say that when it comes to readability, when it comes to ways of writing code, the compactness and personal, preferences play their own role. The code here, the top and the bottom code snippets, they are absolutely equivalent in terms of code, in terms of the generated and compiled code. They are absolutely identical. So it's all about how you like to read it. Personally, I like this. Even though someone may argue that in this case, but also here actually, we have no easy way to, when debugging, to check the value being returned before it is actually returned. Here, it would be relatively easier anyway, to add a local variable to capture the string being returned, and then to check during debug, opening a quick view to check the value. It would be harder to do in this approach. But if this approach is a small routine whose return value can be easily checked at the caller side, this code is more compact and also, in my opinion, gives a better and quicker idea of what's going on. Be idiomatic. Extension methods have been in .NET for years now. Honestly, I never, ever spent time on them. I always disregarded them. They are extremely powerful. I don't know if anybody here attended my talk earlier today about mobile development. Okay. I showed a piece of code in which essentially I was checking whether a HTTP request was coming from a smartphone, a tablet, or a desktop computer using user agent string analysis. Using an extension method, I created ad hoc extension methods for the HTTP request base class in the .NET framework. And an extension method allows you to add a method to an existing class. Or at least, this is the perception of users of extension methods. In the end, an extension method is just a global method, okay, with some syntactic sugar recognized and supported by the C# compiler that makes it look like you are adding a method to an existing class. No way, it's just a way to package global methods, because an extension method is, at the end of the day, is a global static method. But the writability of code is highly improved, because you can write HTTP or whatever it is, request dot is desktop, request dot his smartphone. His smartphone is the global method that receives a request object, runs some calculation, and returns a Boolean value. But one thing is having my helper dot is request, parameter HTTP dot request, and then a Boolean check for smartphone. One other thing is request dot is smartphone. The writability is much and significantly improved. So extension methods. Value objects. A value object is in .NET is a class, immutable class, But more than this, I push the use of value objects in place of primitive types. Integer. An integer can be everything. It can be a temperature. It can be an amount of money. It can be an index. It can be a size. What is exactly the role of a given integer in a function prototype, or worse yet, in an object model that represents and models the data your application is working on? Using of value object as well as using of ad hoc factories instead of constructors, these are two pillars from domain-driven design. And domain-driven design is a methodology for modeling classes to represent in an extremely faithful way the entities and the relationships that populate a given business domain. And again, avoid using primitive types, and don't be afraid of using ad hoc types, even as simple as wrappers around an integer or a pair of integers. Don't be afraid of creating and overloading operators for, summing and subtracting these numbers. But it helps because it raises the abstraction level, thus making easier to understand the purpose for you and for everybody else working on that code. And finally, fluent interfaces are trivially easy to achieve. Every method on a class returns, or with the obvious exception of methods that are just query methods, get methods, every void method returns a reference to this, to the same object. And this allows to concatenate calls, which can also, helps in some cases readability. So don't be afraid of using any of this. So be idiomatic. Be also focused when you model, when you create your code, when you do an analysis on code to see what is the most relevant part. Let me show you a picture. And it will be interesting to see which are the most relevant information in this picture. Well, if I look at this picture, I probably focus over here. But actually, the red area is not centered up here. The most relevant information is the dog that apparently is driving the car. Okay? Be focused also means avoiding what this comic, this Dilbert comic is telling us. With a girl that is a little turned on by hearing that the guy is working on a framework to allow construction of large-scale analytical equations on structured data. Wow, it's exciting. Wow, it's a framework. Okay, if it's simply a framework, you probably don't want to make that complex. Like this. Can you pass the salt? And he waits, he waits, he waits, he waits, up until he complains, hey, I said, I know, I'm developing a system to pass you arbitrary condiments. But it's been 20 minutes, I'm waiting for the salt. Yes, but it will save time in the long run. Again, this is to say that frameworks, complex code, extensible code, you ain't gonna need it. So the balance, readability is also tightly related to the correct application on a project-specific basis of the Yagni, you ain't gonna need it principle. Yes, you don't need any extra code that doesn't strictly belong to the iteration you're in, but sometimes, looking ahead is key, but looking too far ahead, too far away is dangerous. Because, projects are essentially code fast or code right. But if you code right or if you code fast, you never get good code. So it's always and anyway a matter of compromise. And to wrap up things, this is a quote from a developer I found somewhere on a forum. always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. Thank you very much for coming.